I got my first batch of fabricated circuit boards back from OSH Park, and I just wanted to do a video to show the fine quality of these boards and how these I had two different models come back. To get started, you just go to oshpark.com and set up an account, and to make the entire process easy and foolproof, download their design rules and their CAM job files, and as long as you include those in your Eagle CAD design and run periodic DRC checks, you should have no problem. Any overlaps or any connectivity problems at all, it'll alert you. These are I've etched plenty of boards in the past, but this is my first production board. So these are the TSN magneto-resistive lower resolution magnetometer kit boards. This is an Arduino shield. I've got a few components on it, but not yet populated. The boards are $5 a square inch. I had 3 of these made for $24 and some change, free shipping. So you make your design in CAD, and they do top and bottom silk screening. It is a nice, really deep purple solder mask, gold plated terminals, and this is a 2-layer board, but they do up to 4 layers. So you can see how nice and vivid the silk screen is. And I haven't tested these yet. I'll do some continuity checking, but the other batch of boards I have assembled, and I'll show what they're for. So this is the 3-axis digital magnetometer. All I got to do is populate these, which doesn't take long, and I'll have 3 of these ready for purchase, as they are now out of beta. Now for the FluxGate design, here is a sensor from Speak, 4-terminal pin. 4th terminal is not used. So from right to left, you've got 5 volt. 2nd pin is ground. 3rd pin is your frequency output, and the 4th pin is a overwound feedback coil that's not used. And this is one of the 3s, which is their extremely high precision with a resolution of 0.75 nanoteslas. But I found due to the internal makeup of these coils, and while that is kind of a company secret from Speak, I do know that there's at least 2 or 3 coils in there and some microelectronics, so I'm wary of putting a hot iron to any of those pins. And if I absolutely must, I would do it once and keep it at a minimum temperature and for a minimum length of time. And then still, you bury these for long-term use. So to make it more practical, to make a nice, solid, sturdy interface, my solution was an FGM mate, so that any Cat5 Ethernet cable can be used to interface the sensor to the shields that I have in development. So let me put one of these together and I'll be right back. and then you'll see the advantages of using the mates. Like I said, once you plug it in, there's newer versions that have mounting holes and indicator lights on the jack. There's one with an Ethernet cable plugged in, but let me plug one up and I'll be right back. Okay, let's see if I can film, narrate, and do all this with two hands. So I've got the 5-volt terminal marked so I don't get them backwards, and the sensor just plugs right into the right angle header, so that provides a very secure connection. Your RJ, your Cat5 plugs securely into the RJ45 connector, and you can run between 50 and probably 150 feet. In some applications this will not work inside if you've got a noisy environment, electromagnetically speaking. I plan to bury my sensor probably 100 feet away. The new design on the bottom, to get a positive field bias, this terminal end should be facing west. So the new design with the new jack will have connectivity indicator lights. Power regulation happens right at the sensor and filtering. This receives a supply voltage between 9 and 12 volt on pin 1. Pins 2 and 3 are ground. Pin 5 sends back a just a 5 volt logic level, indicating that yes, the power is getting to this and everything's okay. And then pin 8 on the RJ45 sends back the frequency. But the new design will have a west orientation silk screened on the bottom, as well as 2 mounting holes. And another suggestion with these would be to use a little bit of epoxy, and I'll show you what I use. It does take a little while to cure, but I'll show you my recommendation. While these do plug in here pretty snugly, to prevent it from wiggling out over time for whatever reason, what I would do is apply a dab of epoxy to either side where the casing meets the right angle header. And what you can use is you can pick this stuff up at a hardware store or on eBay pretty cheap. It's just some DevCon 2-ton strength plastic steel epoxy. A dab of this on either side, and then put this out in the sun for, I don't know, 12 to 16 hours, and that should cure it. And then that thing will never let go. You can actually thread, once this is cured, you can actually thread this. So it's cheap, and it would ensure that sensor never comes out of its terminal. So for $2, you know, it's some peace of mind. But I'm just really impressed. This is my first batch of production boards, and I chose OSH Park not only because of their prices and their quick delivery, but everything's done in the United States, and I find that important. I don't want to. I try to stay away from overseas vendors for my parts and my fabrication. And this is a quality, very high quality product made right here in the United States. And yeah, for $5 a square inch, I couldn't be any more pleased. These actually look better to me than a lot of retail boards that come back from very expensive fabrication houses. And trust me, over my career I've seen thousands of boards, both prototype and retail. So yeah, the boards are ready. They'll be populated and available. I'll probably just keep 3 of these in stock. I don't know what the demand will be for the lower resolution magnetometers. And a big thank you and props to OSH Park.